Okay, in this video I want to show you how we can discern what the mean and the standard deviation is just by looking at the distribution of the data. We want to see how these things relate. How does the mean and the standard deviation relate to the distribution of the data? So what you see here is you see two data sets. One is red and one is blue. The data values are depicted by these dots. Okay, so these are the red data values. And the value that these dots correspond to is just the position on the number line above. So this dot is maybe negative 0.7, right? This dot is pretty close to 0, maybe negative 0.1. This dot is about 2, right? So each one of these dots represents a number in our data set. So they're measurements that somebody made. Okay, somebody went out into the world, made some measurements, collected the data, and here I've just plotted them as points graphically, right? And then, so we have the red data set and we have the blue data set. Now, you can see that the data sets are a little bit different. The blue data values are clustered closer together, and the red data values are spread more apart, right? So that they have different characteristics. Now, above the number line here, we have some curves. These are the distribution curves. So these give you a sense of where most of the data is in the given data set. So for the blue data, you can see most of the data is right in here. That's why the peak is highest right here. That's where the center is. As we move away from the center of the data, the blue curve tends downwards and goes down to 0 where there isn't any data, right? And then similarly for the red data set, we have a curve for the red data set. The highest point of the curve is indicating roughly where the center is. As we move away from the center, the curve tapers out, all right? And basically the height of the curve is related to the concentration of data, how much data there is around that point. And I have some bars over here, and these are the means and the standard deviations of our data sets. So this is what we're going to play around with. So let's see what happens when I adjust the mean of the blue data set. All right, so I'm going to look at different data sets with different means for the blue. You can see that the data is moving side to side as I adjust the mean, right? When the mean is at 0, right, I see that the center of the blue dots is around 0 and the peak of the distribution is around 0, right? And as I shift the mean to the right, the distribution moves to the right, as do the cluster of blue data values. Same thing with the red, right? So that is how the mean is related to the distribution of the data. It's depicting where the central location of that data is. Well, now let's play around with the standard deviation. What if I adjust the standard deviation of the blue data? Well, let's see what happens here. If I make the standard deviation small, I see that the blue data values all get clustered close together. And the distribution curve peak goes up very high, and the curve gets very narrow. As I make the standard deviation greater, you can see the blue data values are spreading more and more apart, right? So when data values are spread far apart, we have a large standard deviation. And that makes sense because the standard deviation is the average distance that values are from the mean. If on average values are far from the mean, that means they're spread out. If on average the values are not far from the mean, they're close together. That's when the standard deviation is small. And I can do the same thing with the red, right? So this is how we understand means and standard deviations. The mean has to do with where the center of the data values are, and the standard deviation has to do with how spread out the values are. Shifting the mean, changing the standard deviation. Okay, so I hope that just helps elucidate some of the meanings of what mean and standard deviation are actually describing in the context of a data set.